we're going to take a look at one of these types of area between two curves. It's probably a pretty rigorous one. So when we're looking at this, we have y equals x and y equals 2x root 121 minus x squared, and we're binding it in quadrant 1. All right, so first things first, let's graph it. And the good news is I already graphed it on foo plot, and this is what it looks like. Now remember, we're only in quadrant 1, so we don't care about anything that's in this quadrant 3. So we have like this parabolic sort of shape and then the linear shape. And it looks like the point of intersection is going to be a little bit more than 10. So maybe like 10 and a half, 11, something like that, just because the scale is so big. All right. So graph first, and then we'll find the points of intersection just like we usually do. So over here, I'm just going to draw, like I said, quadrant 1, because that's all we care about. So we have this linear function, and then we have like way up here, we have this sort of shape. All right. And this is exaggerated. This is our graph. Clearly, this is the origin where x equals 0. And this is the point we're interested in, right? So to find that point, we're just going to set the two functions equal to each other. So the points of intersection are going to be x equals 2x root 121 minus x squared. To solve this, we want to get rid of the radical. All right, since there's no plus or minus signs in between any of the terms in the radical, we're just going to square both sides. Right, so that's easy, not so easy. So we end up with x squared is equal to square the 2, 4, square the x squared, square the square root, they cancel, 121 minus x squared. We're going to distribute, collect like terms, x squared equals 484 x squared minus 4x to the 4th. Subtracting x squared from both sides, 483 x squared minus 4x to the 4th. Factor out an x squared. So 483, sorry about that. Factoring out the x squared. Then we end up with 483 minus 4x squared. Clearly, we already know that this is x equals 0, easy one. Over here, we're just going to set this to 0. So 483 minus 4x squared equals 0. We're going to solve for x squared. So we're going to subtract 483. We're going to divide by -4. So x squared equals 483 over 4. And now we can take the square root of both sides. So one of two ways that we could write this. We could say x equals the square root of 483 over 4, or square root of 483, and then the square root of 4 is just 2. So that's the precise answer. All right. Now, if we go into Wolfram Alpha, all right, and we just say square root of 483 divided by 2, that gives us 10.9889, which is really close looking at our graph. At least it makes sense. All right, so this is going to be like a little bit less than 11. Okay, so now if it wasn't that, it probably wouldn't be good for us. Okay, then we have to try to start the entire problem over. Okay, all right. Top function is going to be this y equals 2x root 121 minus x squared. Bottom function is y equals x. And this is the point x equals square root 483 over 2. Okay, so let's set up our integral. And for our integral, that's going to go 0 root 483 over 2. Like we said, the top function is going to be that 2x root 121 minus x squared. Bottom function is going to be y equals x. Right. Now, this is actually going to be just looking at this upper bound, it's not going to be an easy sort of computation. All right. It might be good for us to actually get the answer first and then make sure at the end we do get the same thing. All right. So if I just go into Wolfram Alpha and I just integrate, and we have our 2x times the square root of 121 minus x squared minus x where x ranges from 0 to the square root of 483 divided by 2. And this should be a 0, not an O. Otherwise, it's not going to give us something we like. All right. We're going to end up, hopefully, with something not so terrible. 6615 over 8. Okay, so now that doesn't get us any credit on the exam whatsoever, except that we set it up. We actually have to evaluate this for ourselves. Okay, so, but right now we know that the area, at least we know the answer, or at least we think we know the answer. 6615 over 8 is the area. All right, now let's see if we can get there. Okay, I'm going to break this up into two separate integrals because I believe this one's going to need a u sub. Okay, to be able to evaluate that. This is basic. All right, so breaking this up into two separate integrals, 0 root 483 over 2, 2x root 121 minus x squared dx minus integral 0 root 483 over 2 x dx. All right. Now, I'm just going to hold off on doing this one because I know that's going to be negative x squared over 2. No problem. Right? And then obviously there's bounds. All right. But for here, I'm going to let u equal what's under the radical. All right. So we should be pretty good at u subs at this point. Okay. U equals 121 minus x squared. The derivative du is going to be equal to not 2x. All right. Be careful. But it's going to be negative 2x dx. Okay, so the derivative of 121 is 0, and then the derivative of that negative x squared is negative 2x. Right? That means that the opposite of du is going to give us 2x dx, and that's exactly what we want. Okay, we want 2x dx. So now in terms of u, the integral a to b, square root of u, all right, so 121 minus x squared is u, and then times negative du. Okay. Another way to write this is just to turn that square root into the 1/2 power. All right, so that's really nice, just like we've done many times. Not forgetting this, okay, so we're going to hold on to this negative x squared over 2. And so finally, when we integrate, we have this negative that goes out front. It's going to be u add 1 to 1/2 is 3/2 over 3/2, okay, from a to b. And so finally, if I multiply by the reciprocal and clean this up algebraically, negative 2/3 quantity, 121 minus x squared. Okay, so again, just plugging in 121 minus x squared into the x, all right? Plus, we're not forgetting the negative x squared over 2, or the 3/2 power. And then we're not forgetting the really ugly limit of integration that we got. Right. Now beware of this, okay? Notice that we have 0 as a lower bound. 0 does not wipe out all the terms, okay? It will wipe out this last one, all right, but it won't wipe out the first, okay? So let's just plug in term by term. So we get negative 2/3 121 minus root 483 over 2 square to the 3/2 minus root 483 over 2, and that's squared. And then minus the quantity when we substitute 0 back in. So minus negative 2/3 121 minus 0 square to the 3/2. Right. Finally, minus 0 square over 2. If there's any good news about that, that wipes out. Right. Now, this doesn't turn out too badly with the root 483 over 2 squared. So if we simplify this, we're going to end up with negative 2/3 121 minus 483 over 4, since we square the square root of the 2, still raised to the 3/2 power, minus, we have 483 over 4 over 2, and that's really just going to turn into 483 over 8. We'll just do the algebra there. And then finally, when we finish this off, we have this negative 2/3 121 to the 3/2. But we have negative negative, so it's going to turn into positive 120 or 2/3 121 to the 3/2 power. Now at this point, it's probably helpful if we use Wolfram Alpha or a calculator at least. Okay, so I just do everything in Wolfram Alpha because I don't have a calculator to be able to show you, but the syntax is the same, okay, except for the square root button. So I'm just going to type this in term by term so you guys can see what it works out to be. Okay, so moving back here, remember we had -2/3 times, we had 121 minus 483/4. And we raise that to the 3/2 power. All right, so we compute that, -112. Okay, so that's not too bad. Okay, minus 483/8. And then we have this plus 2/3, 121 to the 3/2. So let's compute that. So that goes away, and then the negative goes away. So that's going to be 2662/3. All right. So we know what the answer is, right? Remember a long time ago, this was what we hope to be the answer, 6615/8. Right? So let's make sure we get that. So we're just going to plug in those three values to finish this off. And so we have -112 minus the 483/8 plus 2662/3. And check this out, we get 6615/8. All right, that's really good because now I don't have to re-record the video. So 6615 divided by 8. All right, not the nicest number in the world, but it certainly could be a lot worse. Okay, so that matches up with this, which we found from Wolfram Alpha. That represents this area. All right, so we've seen 4 examples where we've gone through and just integrated with respect to the x variable. There are times where integrating with respect to x is going to cause problems. And what we have to do is we have to solve the functions to make them functions of y, and then try to integrate that way. Right? And in the next video, I'm going to show you guys when that's appropriate and how to do it.